we're looking at determinants, and let's just start off by giving you the definition of a determinant, and that will be where this whole section stems from, is from this definition here. So the determinant and let's put in parentheses here of a 2 by 2, because the 3 by 3 is going to have a little different formula. The determinant of a 2 by 2 of the matrix, and we're going to call the matrix A, so we're just given this, and I'm going to just put in some arbitrary letters here, so those letters just represent any numbers that I want them to be. Alright? The matrix of, the determinant of this is the diagonals multiplied to each other. So what I mean is you take A times D, that's the first diagonal, and then you subtract the other diagonal, B times C. So you can write it as this. That is the determinant of A. And so this is written a little differently. You just use vertical lines on both sides of the A, and you can rewrite this now as the determinant of A B, C, D, and that's equal to A times D minus B times C. Alright, so this is our matrix. We label it as just A. When we're trying to find the determinant, or I'm telling you that the determinant is, you use the vertical lines on both sides of the A. Alright, so the best way to do this is to just jump into an example. Alright, part A, well, let's evaluate the determinant. Alright, and here's part A. Let's say capital A, my matrix, is 6, -2, 5, and 1/3. Alright, so what I want to find, or what I want to determine, is the determinant of A. So then I can rewrite my matrix as the determinant with the vertical lines. Alright, and then from here, it's the diagonals multiplied to each other and you subtract them. And the order matters here. It's this first diagonal, A times D, minus B times C. So it's A, which is 6, times D, which is 1/3. So 6 times 1/3, minus then the other diagonal, which is B times C, or -2 times 5. Alright, keep simplifying, and you get 6 times 1/3 is 2, minus then -10. Alright, these negative times a negative becomes a positive. So we can just write it like this, and that equals 12. Alright, so the determinant is kind of a weird thing that you've never seen before probably, but it is used a lot in the real world, and we're going to take this a step further in a later lecture, talking about Cramer's rule, which allows us to solve for matrices to determine what x and y values that satisfy those equations. Some of the things that in real world applications that you use these in, solving linear equations, which is what we're doing. You can find an area of a triangle. You can, what else? You can determine where 3 points are collinear, and then you can find an equation of a line passing through 2 points. So there's a lot of uses for this. We just need to get used to working these types of problems. Alright, so we'll try one more and see what happens here. Part B. And we'll call this one capital B is equal to this matrix. And we can call these matrices anything we want. They don't have to always be A. So matrix B, we're going to call it 2, -11, 0, and 0. Alright, the first diagonal, 2 times 0, minus the other diagonal, -11 times 0, which, this is 0 minus 0, which is 0. And this is a little subpart of what we're going to get to in Cramer's rule. This is just helping you learn the individual pieces of Cramer's rule. All right, so that's 2 by 2. What we're going to do now is move on to 3 by 3. So let's write this definition. Determinant of a 3 by 3 matrix. This one's a bit more involved, and really it's just the same steps repeated multiple times. All right, and the only thing that's different is going to be really this initial step. So let's say we're trying to find the determinant of this. We'll call it A1, B1, C1. So that's the first system, that's the first linear equation. And then we're just going to name the next ones 2, A2, B2, and C2. And then the third equation, we're going to put a 3. All right, so that's all we do for that. Now, let me focus in here. Okay, so this is going to be equal to a long equation here, but it's going to be made up of 3 different determinants. All right, so the way it starts out first is start with A1, write A1 here, and it's going to be multiplied by a determinant of a smaller subset. So we used A1. You can treat it as, when you do this, you can treat A1 as we took out this whole row and this column. So only thing we're left with are these 4 entries here. So B2, C2, B3, and C3. That's what goes here. B2, C2, B3, and C3. And then we're going to subtract, and now those go away. So we're just moving down the line here. We started with A1. It went here. Now just move down the column. Go to A2. It goes here. And it's going to be multiplied by some determinant. And you can kind of treat it the same. View it like this. You're using this row and this column are now deleted. So now you have B1, C1, B3, and C3 left over. That's what goes here. B1, C1, B3, C3. All right. Now we need to move on to the last one, which we all know is going to be A3. The difference here, though, is we're going to add this one. And so A3 times some determinant. And so we're using A3, so this row is gone and this column's gone. So we're just left with these up here. So it's B1, C1, B2, C2. So it is sorry for the blurriness going in and out. So it is a new, it is new, it's long, but if you break it down into subsections like I did, these become somewhat easy. So example 2. Evaluate the determinant. And here is going to be our matrix A. All right. I encourage you to go ahead and try and do it yourself. Just go slow. Try to think through of where everything goes. Obviously, you can follow the formula for this one. But try to think logically of how I did it. You take the first item here, and now we're not using this row or column, so we're left with this little subset to find the determinant on. So try to set that up and pause the video and then come back. Alright, so what I'm trying to find now is the determinant, so I label it as such. That means the determinant of A is going to be this long thing that I'm going to write. So use a pencil or use some side work, however you want to do it. But I know I'm starting with this top left item. or position, that's 2, and I'm going to have some determinant here. And then, so this 2, I can mark out the row that it's in and the column that it's in, and I'm left with this little determinant here. Alright, and then you can erase these and go back. Now I just move down the line. Now I'm at this 1. So minus 1 times this determinant. So I used this position, so I'll mark out that row and this column. So now I'm left with 4, 2, 5, and negative 1. Alright, now let's erase those. And then now we move on to the next entry, which is this negative 5. Remember, this is a plus, and our entry is negative 5, and whatever's left over here. So this 5, negative 5, you mark out the row that it's in and the column that it's in. So we're left with this determinant here. And now what we have is we have 3 determinants, which we just saw in a 2 by 2. So you have 3 determinants now that you have to work. And then when you find each of those determinants, you're now multiplying by a number in the front. So let's work this out. This 2 stays here. All right. And I'm going to have a lot of parentheses here, so I'm going to start by opening a bracket on either side here. And this is just going to be the result of the determinant. So it's the diagonal, negative 3 times negative 1. And then remember, it's minus times the other diagonal, 0 times 5. And I'll give myself more room next time. Sorry for that being so small. So that's the first determinant. Now this minus 1 comes down, and I need to do the determinant of this thing. So I take the diagonals, 4 times negative 1, minus the other diagonal, 2 times 5. This plus times negative 5. We could rewrite that as minus 5, but I'm going to leave it like this just so we can see everything going on. And now we do the determinant of this subset here. We do the diagonals, 4 times 0 minus negative 2 times negative 3. 2 times negative 3. And from here, it's just multiplying and adding, and addition and subtraction. So just start with what's in the brackets first. The 2 stays out here, so I will get 3 minus 0. Then this minus 1 stays, and what's in the brackets, 4 times negative 1 is negative 4, and then minus 10. And then we have this plus and this negative 5 over here. So here we get 0 minus negative 6. And now let's do some simplifying. This is 2 times 3. I'm going to write it as a parenthesis now because the brackets don't matter anymore. So just to remind you, I only wrote brackets up here because too many parentheses can become confusing. So that's the only reason we're using brackets up there. Then this is minus 1, which we don't have to keep writing that one, but I'm going to just for emphasis, and so you can follow along in your notes later. This is times negative 14 inside, and then plus this minus 5 times, this becomes a negative times a negative is a positive, so 0 plus 6 is 6. And then we're on our way. This is 6. Then negative 1 times negative 14 is a plus 14. Negative 5 times 6 is a minus 30. Alright, and that will equal, this is 20 minus 30, so that gets you negative 10. Alright, so it's not super difficult. It's just learning the process. Taking your time is the big thing, and just making sure you're doing each and every step correct.